Okay, I'm back. We're going to talk about confidence intervals. As I said in the previous video, we were talking about point estimates and interval estimates. The best interval estimate is a confidence interval. It incorporates a point estimate along with the central limit theorem, providing an interval that tells us exactly what the likelihood the population mean has of being in the interval. Okay, so let's look at what's going on here. What we're going to do is we're going to take the population mean. A sample mean. Take a sample from the population. Boom, that's our sample mean. What we're going to do is we're going to put plus or minus a certain amount of distance. Plus or minus some particular distance. Now, do you recall from the central limit theorem what one standard deviation equaled in the sampling distribution? Anybody remember that? Remember, it was related to the population standard deviation. In particular, it was sigma over the square root of n. So what I'm showing right here is the population mean, the sample mean plus or minus one standard deviation. Now, are we always going to want the width of our confidence interval to be one standard deviation? No, we're going to want to be able to make it narrower or wider, depending on what we're doing. So we got to put something here. And I'm going to call that z with the subscript alpha over 2. Now, z alpha over 2 is called a critical value. It's a critical value. Now, whoops, left out a D. Called a critical value. Now, notice how we set this up. This is x bar plus or minus so many standard deviations. There's a problem with that. If you had talking to your roommate about something and you said, oh, I'm plus or minus 2.3 standard deviations, that's true. Would they know what you're talking about? No. How about if you said 1.5 standard deviations? No. So what we're going to have to do is we're going to have to take this number and turn it into something that people understand. Now, something else I want to point out. This was based on a sampling distribution. That sampling distribution, we know when we do these problems, we know that n is going to be large enough, or the original population was normally distributed, that this comes from a normal distribution. And that normal distribution table happens. If it's a normally distributed variable, then those probabilities are true. So if something's got plus or minus 30%, it's got plus 60% middle area. It's got plus or minus 30%. That is actually going to happen. So what we're going to need to do is we need to change this to a value that someone may understand. And usually what we do is we change it to percents. Most people understand percents. And actually, I'm going to make that a whole separate video. Now, let's go back and look at this again. This is x bar plus or minus e, where e is the margin of error. Error. Okay? And if you want to look at this, just this right here, sigma over the square root of n is called the standard error. Okay, now I want to repeat something else. I want to repeat myself. We can guarantee ourselves the likelihood of plus or minus however many. Let me get over here and you see me. The likelihood of plus or minus however many standard deviations we want. Now, when we do that, we convert it into, in the next video, we'll convert that to percents. But suppose we want to be 80% right. Suppose we want to be 90% right. Now, something else that comes up. Suppose you want to be 90% right, but you wanted your confidence interval a bit smaller. Don't you see if you increase the value of n, made n a bigger number, that this would get smaller, and then the interval overall would get smaller? So if you want to keep a particular width in your interval, what you're going to do, and I'll just write the equation up, is you need to find out what value d for n. And that would be, let me make sure I get this right. It's Z alpha over 2 times sigma over the margin of error squared and then round up. So if you're ever in this position, and I'll work an example problem here in a little while, and we will work through this equation. But these are the equations for a confidence interval. The next thing I'll do is develop this critical value, how that comes about, exactly how that works, and then we'll work some problems.